Now in this video, I've got the PNP 8550 transistor AC amplifier circuit. I've got a 6-volt DC source across the transistor. On the collector side, I have a resistor. On the base, a resistor, and coming off the base, I've got a 20 millivolt peak-to-peak 1 kilohertz sinusoidal input in series with a 22 microfarad capacitor. Now what I'm going to do first is I'm going to find the value of my resistor on the collector side. Now I want 3 volts across my resistor. Now I've got a 6-volt source. So if I have 3 volts here, I'm going to have 3 volts here. Now I also want a collector current of 1 milliamp. Now what I'm going to do is I'm going to find what my resistor value should be. So the value of my collector resistor equals 3 volts divided by 1 milliamp. Three volts divided by 1 milliamp. That gives me a value of 3 k ohms. Now I'm going to find my base current. And after I find my base current, I'll find the value of my base resistor. The beta of my transistor equals 300. So my base resistor current equals 1 milliamp divided by my beta of 300. And that gives me a value of 3.33 microamps. 3.33 microamps. Now I'm going to find the value or the voltage of my base resistor. But first, I need to know the voltage across VBE. 1 milliamp will give you a voltage across VBE of 0.6 volts. Now I will use 0.6 volts and my 6 volts, and I will find the voltage across my base resistor. I'm going to call it VBR. That equals 6 volts minus 0.6 volts, and that gives me a voltage of 5.4 volts. Now I will find the value of my base resistor by dividing 3.33 microamps into 5.4 volts. 5.4 divided by 3.33 microamps, and that gives me 1.6 megohms. So I'm going to need 1.6 megohms for 3 volts here and 3 volts here. Now what I'm going to do is I'm going to apply my 20 millivolt peak-to-peak signal. The idea is that I apply the signal and I get a much bigger signal out here. So now the question becomes, exactly how do I find out what the magnitude of this signal will be? In order for me to know how big my signal will be, I need to know the voltage gain. And the voltage gain equals 3k ohm times 1 milliamp, all divided by the thermal voltage of 26 millivolts. And that gives you a gain of 115.38. So now the question becomes, what do I do with the 115.38? Well, I multiply it by my 20 millivolt peak-to-peak input. So my Vout will have a peak-to-peak output of 2.3 volts. So my signal on the output will look like this. And the peak-to-peak voltage will be 2.3 volts. And you have something else going on here. The signal has been raised up 3 volts. Now what I'm going to do is I will find the top voltage and I'll find the bottom voltage. Down here you have 10 millivolts at the top. And you have a minus 10 millivolts at the bottom. So now what I'm going to do is I'm going to multiply 115.38 and I'm going to multiply it by 10 millivolts. And that will give me 1.15 volts rounded off. Now I will add 3 volts. That will give me 4.15 volts at the top. .15 volts. Now I will multiply the 115.38 and I'll multiply it by minus 10 millivolts. That will give me minus 1.15 volts. Then I'm going to add 3 volts. And that will give me 1.85 volts at the bottom. And so what has happened is that the signal not only has increased in magnitude, but it's also been raised up by 3 volts. And this brings me to the end of the video. Like, share, subscribe. Like, share, subscribe. Thanks for your attention.